allow light to shine.
But you need to be more specific with what properties of light you want.
But I want the four of them. The reflection, refraction, diffraction, and interference.
If that's what you really want, then let's explain it one by one. Let us first start with reflection. Reflection refers to the bouncing back of light. One example of this is when a person is standing in front of a mirror. The light from the person is called an incident ray, and the light that bounces back is called the reflected ray.
Another example of reflection is the wall where the light from the bulb serves as the incident ray and the light that reflects in the reflected ray. Another property of light is the refraction. This happens when the light bends as it passes through one medium or another. It is caused by the difference in density between materials. An example of this is a glass filled with water. As you point a flashlight on top of the middle of the glass inside a dark room, you can see the bright light pattern due to refraction.
Another example of this property is when you put a pencil in a glass of water. The pencil will appear misaligned due to the light that passes through the air and water that has different densities, causing it to bend. The third property will be diffraction. It is the bending of light around corners that spread out and illuminates areas where shadows would be expected. An example of this is when you are inside of a dark room with a closed door where you can see the light from the other side pass through the door slits between the door and the doorway.
Another example, the compact discs. As the light hits the CD, some light is diffracted while some is reflected. That is why we see rainbows on compact discs. Lastly, the interference. Interference is the phenomenon in which two waves combine to form the resultant wave of the lower, higher, or same amplitude. An example of this is when gasoline was spilled into the water. As the ray of light hits the surface of the oil, it gets reflected by the top and the bottom surface of the layer. This causes the colors contained by the light radiation to undergo constructive as well as destructive interference. The construction interference of colors of the light leads to the formation of the multicolored visible pattern on the surface of the oil.
Another example of this can be seen in the soap bubbles, where light is reflected on the top and bottom part of the bubbles, causing different waves to interfere from different colors of light.
Now, let the light shine!